From so many teachers of the Book of Mormon, we learn much about the lives of the Nephites. We learn about their righteousness and wickedness, their blessings and cursings, their teachings and morals, the wars and peace, the intrigues, betrayals, murders, repentance and renewals of their faith, their weapons of war and their tools of work, their clothing and their costumes. What we never heard of is about their commerce, how they count, how is their numeration system, their numbers according to their reckoning. We begin expounding on this subject by reading from the Book of Mormon. In Alma, chapter 11, verses 5 through 18, this is what we read. Now the reckoning is thus: a C9 of gold, a Zion of gold, a Shem of gold, and a Limna of gold, a Sinam of silver, an Amner of silver, an Isram of silver, and an Untai of silver. Sinam of silver was equal to a C9 of gold, and either for a measure of barley, and also for a measure of every kind of grain. Now the amount of a Zion of gold was twice the value of a C9, and a Shem of gold was twice the value of a Zion, and a Limna of gold was the value of them all. An Amner of silver was as great as 2 Sinums. An Isram of silver was as great as 4 Sinums. An Untai was as great as them all. Now this is the value of the lesser numbers of the reckoning. A Shiblan is half of a Sinum. Therefore, a Shiblan for half a measure of barley. A Shiblan is half of a Shiblon, and Eli is half of a Shiblan. Now this is their number according to their reckoning. From these verses, we can draw charts for the gold and silver values. These charts help us visualize their number system. C9 represents the amount of gold that has the equivalent value of 1 measure of barley or any kind of grain. We therefore equate 1 C9 as having a value of 1. The amount of a Zion of gold was twice the value of a C9. Therefore, it has a value of 2. A Shem of gold was twice the value of a Zion, which value is 2. Therefore, a Shem of gold has a value of 4. And a Limna has the value of them all, meaning 1 plus 2 plus 4 equals 7. So if you have gold, you can start counting. If you want 1 measure of barley or any kind of grain, all you need to have is 1 C9. And if you want 2, you need 1 Zion, which has a value of 2, and no C9. If you want 3, you need 1 C9 and 1 Zion. 2 plus 1 equals 3. And if you need 4, you need 1 Shem, which has a value of 4. And if you need 5, you need 1 Shem and 1 C9. If you need 6, you need 1 Shem and 1 Zion. And if you need 7, you need 1 Limna. And if you need 8, you need 1 Limna and 1 C9. And if you need 9, you need 1 Limna and 1 Zion. 1 limna and 1 sham equals 11. So that is how we count the gold. Now let's take a look at the silver. As we have read in verse 7, 1 sinum is equal to 1 C9, which has a value of 1. So a sinum of silver has a value of 1. An amnor was as great as 2 sinums. So the amnor has a value of 2. And an isrom has a value of 4 sinums. So since sinum is 1, isrom has a value of 4. Now to the lesser amounts. A shablan is half of a sinum. So it has a value of 1/2. And a shablam is half the value of a shablan. So it has a value of 1/2 of 1/2, which is 1/4. And Eliah has a value of half of a shablam. Therefore, half of 1/4 is 1/8. That is their value. You will notice that if we double the rightmost column, it becomes the next column to the left. So if we double the li, which is 1/8, it becomes 1/4, which is the shablam. And if we double 1/4, it becomes 1/2, which is the shablan. If we double 1/2, it becomes the sinum, which is 1. And if we double 1, it becomes 2, which is the amnor. And if we double amnor or 2, it becomes 4, or the isrom. So you will notice here that the series is multiplying by 2. Now, our number system is not like that. Our number system is decimal. It's based 10 on 10 fingers. So the first column represents 1. The second column is 10. The third column is 100. The next is 1000. So here you have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. The 10 goes here as 1. Okay. So every number here represents 10. And every number here represents 100. And here 1000 and so forth. So if we have a number such as this, if we have a 2 here, it represents 2. And if we have a 3 here, it represents 30. 3 times 10. And if you have a 1 here, it represents 100. So this is 100, 30, and 2. And if you have a 2 here, 2132. So that is the decimal system. That is not how they count. So to make it easily understood, let's not get confused. Let us multiply every number by a common number in order to remove the fractions. So we will multiply each of these by 8. By multiplying each of these by 8, the ratio between columns is the same. So 1/8 times 8 is 1. 1/4 times 8 is 2. 1/2 times 8 is 4. 1 times 8 is 8. 2 times 8 is 16. 4 times 8 is 32. So we maintain the same ratio. You got 1 here. If you double 1, it becomes 2. You double 2, it becomes 4. You double 4, it becomes 8. You double 8, it becomes 16. You double 16, it becomes 32. But each value of this is now 1/8 of the original measure. So we will now call this a new quantity, and we'll just call it 1 unit, which represents 1/8 of the original value. So 1 li is a value of 1, so this is 1. You want 2, you need 1 cheblon, which has a value of 2. So you need 1 cheblon and no li, and that will be 2. You want to have 3, you need 1 li and 1 cheblon. 2 plus 1, 2 plus 1 equals 3. If you need 4, you need 1 cheblon, which has a value of 4, and no cheblon and no li. You want to have 5, you need 1 cheblon and 1 li. 4 plus 1 equals 5. And if you need 6, you'll have 1 cheblon and 1 cheblon. 4 plus 2 equals 6. And if you want 7, you need 1 cheblon, 1 cheblon, and 1 li. 4 plus 2 plus 1 equals 7. And if you need 8, you need just 1 sinum and no cheblon, and no li. If you need 9, you need 1 sinum and 1 li. 8 plus 1 equals 9. And if you need 10, you need 1 sinum and 1 cheblon. 8 plus 2 equals 10. And 11 is 1 sinum, 1 cheblon, and 1 li. So it can go until you consume all the columns. The counting system, as we have seen, is not based on 10. It's based on 2. So now let's try some arithmetic operation. We shall try 3 plus 4. So 3 plus 4. 3 in our chart of silver is 0, 0, 1, 1. So let's use that. 0, 0, 1, 1. And 4 is 1, 0, 0. So 1, 0, 0. 0 here. 1 plus 0 is 1. 1 plus 0 is 1. 0 plus 1 is 1. 0 plus 0 is 0. So what is 0, 1, 1, 1? 0, 1, 1, 1 is 7. So this is 7. So 3 plus 4 equals 7. So it adds up. Alright. Let's try another set. 5 plus 9. 5 on our chart is 0, 1, 0, 1. That's 5. And 9 is 1, 0, 0, 1. Now you'll notice here that this is going to be a 1 plus 1. But this is not a 2 this way, because it's not like that, you know. 1 is li, and another li is 2 li. 2 li is 1 cheblon, okay? And 1 cheblon is 1, 0. So 2 li is 1 cheblon is 0, 1, 0. That's or 0 carry 1. Okay. So 1 plus 1 equals 0, carry 1. 1 plus 0 equals 1. 1 plus 0 is 1. 0 plus 1 is 1. So what is 1110 from our chart? Okay. 1110 is 14. So it's 14. 5 plus 9 is 14. So it works. The number system of the Nephites is base 2. It is called the binary system. Today, the binary system is used in computers, the only number that machine can understand. 0 means off and 1 means on, or close, open. It means light or dark, or magnet or no magnet, hole or no hole, absence or presence of something, tall or short, high or low, hot or cold. These are machine readable information, and the computer can read them. Now let's go back to the gold chart. It is not true binary series in the sense that it is not 1, 2, 4, 8, but rather it is 1, 2, 4, 7. If you do a binary calculation, it will not add up. But in 2005, I found out that the United States mails have zip codes, not only in numbers, but also in optical codes readable by machines. Here are some of them. Now there is the zip barcode in here, and here is the zip code. Zip barcode and the zip code. The zip barcode and the zip code. We have here the zip barcode, which I already divided into segments. There you go, zip barcode, and another zip barcode. Now let's compare the zip barcodes with the tables of the gold. Now what I did here is divided the zip code into segments, and every segment contains 4 bits of information. The shorter or the low signifies 0, and the high signifies 1. So for example, in this is low, 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 high means 0, 0, 0, 1. And the second one is low, high means 0, 1, 0, 1. So we will use the gold chart and see what are the values of the segments. So the first segment is 0, low, 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 high, or 0, 0, 0, 1. 0, 0, 0, 1 is 1. So I'll put 1 here. Okay. Segment 2 is low, high, or 0, 1, 0, 1. 0, 1, 0, 1 is 5. So that's 5. Then the third segment is low, low, high, low, 0, 0, 1, 0. 0, 0, 1, 0 is 2. So I'll put 2 there. The fourth segment is low, low, high, high, 0, 0, 1, 1. 0, 0, 1, 1 is 3. Segment 5 is high, low, low, high, 1, 0, 0, 1. 1, 0, 0, 1 is 8. Segment number 6 is high, low, 1, 0, 1, 0. 1, 0, 1, 0 is 9. So I'll put 9 here. Segment 7 is high, low, 9, 1, 0, 1, 0. So it is 9. Segment 8 is high, low, 1, 0, 0, 0. 1, 0, 0, 0 is 7. And segment 9 is 0, 0, 0, 1. 0, 0, 0, 1 is 1. So I'll put 1 here. So by using the gold chart, we got 1, 5, 2, 3, 8, 9, 9, 7, 1. So what's the zip code? 1, 5, 2, 3, 8, 9, 9, 7, 1. 1, 5, 2, 3, 8, 9, 9, 7. So it works. So what have we done? We have decoded the USPS bar zip code by using the gold chart of the Book of Mormon. So what does this mean? It means that the binary system, which is used in our computers today, signifies the computer age, and the bar zip code signifies the nation, the United States, that uses this bar zip code. There's no other nation that uses this. So it refers to time and place. Computer age and United States. And this is the time and place. I've been asked many times how I came to know about this. And my answer is, it just came to me as a gift. It's a gift of the Spirit. It's personal revelation. I'm not speaking for any church. I'm not teaching any doctrine or any articles of faith. I'm just doing this for fun, for diversion. So have fun. Thank you. In 2011, they started to remove this type of barcode, and they gradually replaced it from this to this. And then in beginning 2012, all of the mails are in this type of barcode. So with this change in barcode, the gold chart is no longer valid.